Hello everyone. So in this series of videos, I would be talking about the topic of three-phase alternating current systems. So there are different ways of connecting a three-phase system, and we will be closely examining different types of three-phase AC circuits. So we had in earlier videos looked at one-phase AC circuits and how to solve one-phase AC circuits. So this is a continuation. So let's look at the three-phase system. So what exactly we mean by three-phase system? So it's a set of three voltages, a three-phase system, given by values something like this. So I can take EA as some magnitude. First, let me write a generalized equation, and then I'll be writing the numerical equation. So instead of EA, let's call it VA. So this is the voltage of phase called A, and let's say it is some maximum voltage sine of omega t. So you had seen this. This is a single phase AC, so very similar to that. Now I define another voltage VB, which is the magnitude is same, the maximum voltage is same, and the frequency is also same. So as remember, omega represents the frequency. Omega is nothing but 2 pi f. So where f is the frequency in hertz, omega will be in radians per second. So how many radians in 1 second is covered is given by this, and t is the time. So time multiplied by radians per second, it will be in radians. So sine will be having in radians. So this is about the units. So what happens here is minus 2 pi by 3. So this is a phase shift that is introduced into the second voltage, which we are calling as VB, and then VC is the third voltage. It will have a further phase shift of 2 pi. So this is already minus 2 pi by 3. So I'll once again minus 2 pi by 3. It will become minus 4 pi by 3. So this is a set of three phase voltages. Now you can say voltage is always with reference to 2 points. So where is the other point? So this is, you can imagine as a coil. So if I show the physical diagrammatical representation, let's say this is the stator of a machine, and inside the stator there is a magnet. So let's say this is the north pole of the magnet, and this is the south pole of the magnet. Forgive my bad drawing. This is north pole and this is south pole, and this is the A phase winding. So I'll denote it as A, and this is the other end of the this one denoted by A dash. So whenever the magnet this poles are rotating, it will flux are cut by this coil A dash, and then EMF is induced when the rate of change of flux linkages is maximum, and then EMF induced is less when the rate of change of the flux linkages is minimum. So that is just general principle of working of this particular machine. Now, of course, this course we are not going in depth into the machine. This is a power system course, so I'm not going in depth into the construction of the machine. So let's continue. Now, if I define this as my axis, and then let's say this pole is rotating like this. So physically, let's say this is 90 degrees and this is 120 degrees. So at this location, I'll keep the another coil B dash. So this angle, the axis of A dash and axis of B dash, they are separated by angle of 120 degrees. Then further 120 degrees, I'll keep, so from 120 degrees from here, it will come somewhere here. So this I'll call it as C, and this is the other end of C dash. So if I do like this, then the EMF induced in the A winding will be ahead of the EMF induced in B winding in time. And then because first A winding is being cut by the magnet, and then B winding, and so on. So now if I go up, now I hope this drawing will make sense. You see A winding, right away it is EMF is induced, but the EMF induced in B winding after an angle of 2 pi by 3 after some time. So how much time? So here you can through this omega you can find out how much time is there in that this one. We're going to see that. So by physically locating the three coils around the machine and generating EMF through a magnet, we are getting a EMFs induced which are differentiated by 2 pi by 3. So 2 pi by 3 is nothing but 120 degrees. So remember pi is nothing but 180 degrees. So 2 pi will be 360 degrees and divided by 3 will be 120 degrees. So this is for the three phase system. So if this is a phase voltage, then this represents 90 degrees, this represents 180 degrees. So from somewhere from here, the B phase voltage will start. And after, of course, there will be a negative side of this, and then somewhere here, the C phase voltage will start. So something like this. So in order to further understand this, let's just plot these equations. So if I go up, let me give some numbers. Let's take omega is 314. So why I have taken 314? So it corresponds to 50 hertz because if frequency is 50 hertz, this is radians per second, then 2 pi f will be nothing but 2 into 3.14 into frequency is 50. So 50 into 2 is 100. 100 into 3.14 will be 314. So this is my omega. And similarly, V max, let's take it as 10 volts. So if I have three voltages described by the equations like this, that is VA, VB, VC. I'm just writing it in the form of a matrix is equal to 10 sine 314 into time 10 sine 314 t minus 2 pi by 3 10 sine 314 t minus 4 pi by 3. You might ask a question, why minus, why not plus? So that will be a different phase sequence. If because we want to introduce a delay, that's why I'm putting minus. We can always cross check that. So let's plot this function using MATLAB environment, see how it will appear. So in order to plot these functions, let me just shift to MATLAB view. So here it is. So I just use a function called fplot, and then I'll just give these three functions. So fplot is a inbuilt function in MATLAB, and in fact I am using Octave software, which is open source version of MATLAB. So I'll just do that. So 10 into sine of 314t. So instead of t, I have to use the variable x because that is what this fplot function takes. X as the variable. So 10 sine 314 into x. This is the first variable, first voltage. 10 sine 314 into x minus 2 into pi by 3. Again, one more is 10 into sine into 314 into x minus 4 pi by 3. So this is my set of three voltages. Now I also have to give the limits for plotting the function. So limits will be in terms of x-axis, that is in terms of time. So now for a frequency of 50 hertz, 1 by 50 is 0.02, that is 20 milliseconds. So if I want to plot 4 cycles, I'll use 80 milliseconds. So 0 to 80 milliseconds. So or 80 by 1000 seconds. So I'm just giving that as a x-axis. So I think somewhere I did some mistake. Oh, I think these commas are not required. So let me remove these commas. So let me just check with my previous prompts what I did. Yeah. So I think this will work. So here on your screen, you're able to see the plots. So I think this is only two. Let me do the third one. Okay, sorry for the confusion. So yeah, 10 into sine 314 into x minus 4 into pi by 3. I might have done some uh, syntax error in the previous one, so this should work. So I am plotting three functions. So here you see on the screen you can see that. So this legend is somewhat abstracting. So let me turn off the legend off. So now what you can see on your screen is 0 seconds to 8 or 80 milliseconds, 0.08 seconds or 80 milliseconds. So the first blue line that you are seeing is the A phase voltage. Then the B phase voltage is starting after 120 degrees like this, and then the C phase voltage is starting. That is in the red color. It is something like this. So this is a set of three phase voltages which are coming like this. Now at any instant, the addition of all three will be zero. So that's another interesting characteristic of a three phase system. So for example, take at the instant of or maybe at this instant where these two are minus 5 whereas the other one is plus 10, so the addition of all will become 0. Similarly, if you take at this instant the blue colored voltage, that is the A phase voltage, is plus 10 whereas the other two are minus 5 and so on. So at any point all these three addition it will be 0. So anyway, we'll check that. So I thought I will just visualize these voltages for you, so that's why I have done like this. So let's go back to our thing. So this is about the three phase voltages. So now, how the three phase voltages are generated? They are generated because the coils are placed 120 degrees apart. Now I'll talk about the connections. So there are two types of connections, three phase connections. So one type is called star connection, or it is also called Y connection. So WYE, to write it as English word Y connection, and this is the symbol. This is the star connection. Another way of connecting is delta connection, and this is the symbol for that, and it's also called mesh connection or whatever. So what is star connection? What is delta connection? So if you have three voltage sources, so let's say this is the voltage source 1, voltage source 2 and voltage source 3. This one is generating voltage of 10 volts at a phase angle of 0 degrees. This one is voltage in 10 volts, phase angle of minus 120 degrees. This one is generating 10 volts and phase angle of minus 240 degrees. This corresponds to minus 2 pi by 3, minus 4 pi by 3. So what I'll do is, so let's say this is A phase starting and A phase ending. This is B phase starting and B phase ending. C phase starting and C phase ending. So let me just make a copy of this. So we'll come back to the copy later. So what I want to do is, this is the starting, this is the ending. So all the endings, this is the ending, this is the ending, this is the ending. All the endings I'll just connect to the common point. Something like this. And then all the starting points I'll take out as my supply voltage. So this is terminal A, terminal B and terminal C. So this is called star connection. So when you're connecting all the ends at one point and then all the other three terminals outside is a star connection, and this is basically three wire supply. Now I can also take this common point and also get that common point outside as a neutral wire. So this is a three phase four wire supply. If I don't include the neutral wire, then it is a three phase three wire supply. So let me just write this neutral. This is a neutral wire. Okay. Now come to the another way of connecting. So what you do is, the ending of the first winding you connect to the beginning of the next winding. The ending of this winding, again you connect to the beginning of this winding. Similarly, the ending of this winding, you connect to the beginning of the other winding. And then you take out either this side or this side, you can take out the, so let me connect it from this side. So basically it becomes a closed set of connections. Then the A terminal, I can take it out. B terminal, I can take it out. C terminal, I can take it out. Then it becomes again a three-phase supply, A, B, C. Notice that here I cannot define a neutral terminal because they are all connected like this. So more simpler notation. So this is delta connection. So more simpler way to draw in a circuit is something like this. This is a three-phase supply. So now this is like plus minus plus minus plus minus. The endings are all connected together. So this is VA, VB, and VC. If I denote this as N, so then VAN will be the voltage here, and so on. So this terminal is called ABC. So this is star connection, and the delta connection will be something like this. Now this one is called A. Let's use a constant notation. So if this is VA and this is plus minus, then the positive side of VA, that terminal I call it as A. Similarly, now you look here, the positive side, this is plus minus, plus minus, plus minus. The positive side of B is coming out as a B terminal. So if I define this as VB, in fact I'll have to define this as VB because the negative terminal of A is connected to positive terminal of B, and this one is called as B. So this is A, this is B, and then finally this is VC, and the positive terminal of C is connected to the negative terminal of B. You can see here negative terminal of B is connected to the positive terminal of C, and then this one we're calling it as C. So A, B, C. So this is the voltage sources which are connected in the form of delta, voltage sources which are connected in the form of star. So this is delta connection. So in the next video, we will look at each case, star connection and delta connection, and observe the relation between the line voltages and phase voltages and so on. So this is just a first brief introduction about how three-phase voltage is generated, how they are differentiated in phase, and then finally how they are connected. The two ways of connection we have discussed. See you in the other video.